This is a production of Cornell University.
Okay. Well, then I'd like to just take a moment here to thank Dr. Taylor as well here, that I've had the pleasure of working with him on a number, as he mentioned, a number of presentations he's done for us. And I know whenever he does make it to Ames, why it's usually a great opportunity to go to lunch or something and discuss things that have changed in the industry, you know, the different trends. And he's always a wealth of information on some of the, you know, the more specialized seed treatment applications and some of his research. And I can show him a little bit on what we see on the equipment and so forth. So today it's kind of a pleasure to be able to share some of it without having to get on an airplane and fly someplace. So there are, you know, some mixed advantages, I guess, in the situation where everything seems to be on Zoom these days. But also, I am trying out a few pieces of technology as we're debating what to do with our workshops for this next year, and so we want to be able to do some of it virtually if we need to, and I'm testing part of that in technology here today. We'll, as they like to say, you know, technology is great as all when it works properly. So we'll see where it goes. Again, so I can switch back and forth. We'll try to take a break a couple times during this presentation, at least maybe follow up on the chat and some other things with it. Likewise, I apologize if I'm jerking back and forth a little bit like this because I am running 4 monitors here. So it's tough to always look at it and still see it without getting further back away. So with that, like to go ahead and we'll get started. As he mentioned, about an hour and a half of stuff. I like to joke with the students that we do handle in for the academic classes that humans have been cleaning seed for several thousand years, and we're going to cover all of it the next, you know, in this case, an hour and a half. So frequently highly caffeinated presentation, but if you can bear with me, and we'll take it from there. Dr. Taylor's mentioned a few of the things that we do. This was the seed science building early on and a floor plan from it. So I spend most of my time in the elevated part of the building here or right next to it in my office. And, you know, there's just a view from the north side. Fortunately, we don't have the snow today, but that could happen most any time. And as you mentioned, I do a lot of seed conditioning workshops or, you know, seed processing as it's known elsewhere in the world, but where we work with industry on different topics that, you know, would be relevant for people working in the plants. I do a lot of student lab sessions for various academic labs where we'll do 1 or 2 labs and a couple of lectures or something to give them the content that's relevant to that class. We do some of our own research on seed conditioning and help work with an awful lot of researchers. I joke that I see a small piece of a lot of projects where they need to clean or sort or treat, or this lately people have been counting seed like crazy once they got done shelling this fall. So a little bit on the workshops. There may be a few people on here that have been to the workshops before. And if so, you know that we have the students that work for me put a poster together at the end of each year. And one of the first things I see people do when they come to the workshops is they run in to see if they got on the poster, because it's really a photo montage that the students put together. And so there was 2018, if anybody happened to be there, as well as 2019. And they're really not a highly technical poster, just a lot of fun. And I joke that the students take a lot of photos because if you fill the poster with pictures, you don't have to write very much. So with that, today, what I'd like to take some time to do is to kind of review, more or less in this order, a few basic concepts. This is kind of seed conditioning 101, but we're going to be talking about some of the concepts that are involved here, a little bit on handling, a little bit on drying and so forth up front. Basically, some of the post-harvest operations that kind of cause problems sometimes for people. And then most of what we're going to be talking about is dry granular separation, you know, the things that we're doing to clean and sort and upgrade the seed. And I'm going to introduce a few quality control concepts as we go. And again, the whole business on the equipment, I'm going to show you a little bit on plant operations, some of the key principles. We're really not going to be able to get into adjustments much on this time. I joke sometimes that I spend the entire summer talking about this, so I run out of time then. So the likelihood of covering everything in an hour and a half isn't real great. So first off, you know, is you're maybe working on, I know you're an hour ahead of me, so you're probably on that second cup of coffee instead of the first, but why are we doing this in the first place? If it really has to do with getting this ready for market. Okay, if it's seed corn, which we have plenty of here in Iowa, it comes in on the ear, it's very high moisture, husks and so forth on it, certainly not ready to put in the bag. And so a lot of things have to happen to get that at least cleaned and sized and sorted and then ultimately treated. If it's something a bit easier, we joke here sometimes in Iowa that, alternative crops means corn and soybeans. Realize you've got a more diverse mix out there. Fortunately, we do work with a lot of other things at Seed Science than just the general field crops that we'd have here. But soybeans, again, are a bit easier. We may have to get splits and weed seeds and, moldy, discolored seeds and other foreign material out. And I get into some food grade products as well. So these were dry beans. The little maroon colored ones here are Adzuki beans. Typically for export to Japan, but this happened to be an organic seed lot where weed control got out of hand. So if somebody needed a bunch of ragweed, we did develop a process for cleaning those up for seed. So again, I tend to take a kind of a broad brush approach here to seed conditioning, and it's basically the post-harvest operations that we'd be involved at a plant. So anything from perhaps secondary threshing, a lot of drying, cleaning things up. I do get into seed treatment and whatnot as well. However, that's going to be covered in substantially more detail this afternoon. Okay, I understand you have some people that are doing stuff that are not just corn and soybeans. So when I get into, this was flax, it's an indeterminate crop where they're not mature at the same time. Sometimes the different grasses may have to be stripped a few times. Things like fruit or tomatoes, how do you get the seed out of there? You get into extraction. We're not going to cover that today, but I just want to bring up, many of the issues that would occur. So we wind up with a range of different workshops to try to cover, those topics. Again, as Dr. Taylor mentioned, I've been hanging around this business since the early 80s. And when I started on this, a lot of my clients that I'd worked with for plant design were mom and pop type operations. That certainly changed over the years. A few of Midwestern plants here have been added just to kind of show you the scale of the operations that we often deal with. So I have I'm fortunate to be able to work with everyone from small mom and pop companies to some of the big multinationals. Okay, if we start just taking a walk around a seed plant, which sort of what this is, we're going to more or less follow the flow. The different components would be, things related to, receiving the product, drying and temporary storage. There's a lot of handling that goes on. I'm going to just briefly cover, most of the issues that are raised by that today, and a little bit on some physical separation, with a lot on that actually today. And then again, just introduce the treating, and we'll finish with a couple of slides just to finish our walkthrough on the plant. Again, most of what we're going to be covering today is a little bit on the material handling and lots on cleaning and sorting. Okay, just a couple quick comments. Things that go wrong. I said I work with post-harvest, but the typical complaint that I hear when I'm talking to seed plant people is that the combine operator did something wrong. Okay, either they beat the seed up or they didn't clean up properly between. Varietal contamination is a huge issue and something that we can't magically remove unless there's some difference between the two varieties that we can use. The other big thing I run across is the need to properly dry and store, the seed. If we can control the moisture coming in, properly aerate it, we can do a lot of things to help maintain that seed. And sometimes, drying to a safe level is an important part of it. I see too many cases where things go wrong. Moisture really does matter. And, there's just kind of a list here. I'm not going to go through all of them, but things that we wind up talking about on moisture. And sometimes when I have the luxury of doing this in seed science, I can bring in some of our speakers, much like Dr. Taylor talked about Cornell speakers. We have Iowa State speakers that'll come in and hit some of this, as well as other guest instructors. So then the other big thing, again, I work in the same building as the seed testing lab. They have a lot of different tests that are run, but at a plant, sometimes we're looking for very simple tests that are often based on the same physical properties that we might use in the machine. So if we're checking a cleaner, we might use hand screens or something to see if it's doing the right job. I mentioned moisture. That's probably the first thing that's checked. Some of you may be familiar with taking test weight, how many pounds per bushel. Perhaps you get this from your moisture meter. We frequently are looking for broken seed, testing for seed coat damage on things like soybeans here. I mentioned seed counting earlier, that the grad students have been counting and counting. We had seed counters running literally 40 hours a week or more here for the last month. But, so the number of seeds per pound or 1,000 kernel weight can be important. Sometimes we're grading for visual defects, depending on what we're looking for. And this gets beyond the scope today, but packaged units and so forth, what's the weight of the bag and meeting regulatory requirements. And then I'm an engineer, so we put numbers to about everything, but, capacity, percent discards, yield and whatnot. Okay, so again, whatever mentioned that there's typically large volumes of stuff going through. That may not be the case if you're dealing with tomatoes or perhaps pumpkins or something, but many of the field crops will have a lot of material handling equipment moving things from point A to point B. Depending on where those points are, could be elevator legs going straight up, belt conveyors and inclines or horizontal, some technology that's borrowed from the grain industry sometimes for filling bins. A lot of vibratory conveyors within the towers and pneumatic conveyors to blow more often discard, but sometimes other product. Whatever goes up must come down. So we've got some gravity spouts and letdowns in here as well. Okay. One big problem with all this mechanical handling can be damage. Okay. We might break or hurt the seed somehow. I like to joke sometimes that whatever the gravity separator and the color sorter or cleaner giveth, the handling system can take it away. So we want to be careful about that. Again, soybeans are almost a poster child for mechanical damage. I joke sometimes if you look at them too long, they might break. But you see most of the studies on it. This was an early one I was involved with as an undergrad, actually, but looking at the effects through 6 different plants over the course of the winter and sampling everything. They tried to include one screw conveyor at the beginning, an auger, and lost over 2% damage on the average just for that in germination. And there was also a moisture effect. Dry soybeans tend to break more easily than regular moisture. So again, moisture matters on that point too. You can over dry product and have issues with that. So probably the biggest single thing, without going into every possible machine you might have, is that this really boils down to not hitting things too fast or being in the wrong place at the wrong time. So if you can reduce seed velocity, maybe we can reduce drop height, we can slow the machine down. Sometimes we can use a larger conveyor and run it at a slower speed to handle the same capacity. If you have maybe a screw conveyor or something in here, using a lowest possible incline, don't raise it up too far and then drop it farther down. And again, being in the wrong place involves impact or abrasion or being crushed by a machine somehow, or being sheared off, being cut by a sharp edge someplace, so we can eliminate some of those pinch points. Brand new equipment frequently has nice sharp edges coming out of the factory, so running that in for a while can be useful. And trying to keep most of the conveyors running full can be important. That isn't maybe so critical on belts or something, but again, rubber or plastic contact surfaces, if you hear a lot of noise with stuff crashing into steel, there's usually a good indicator that there's some damage as well. And most seed companies I work with do try to modify the conveyors to avoid these problems for obvious reasons. There is some evidence of soybeans being sensitive to cold temperatures. And it's somewhat anecdotal, but there's at least split generation can be worse. Those of you that happen to get into it, we have lots of discussions on how cold that may be, but we'll leave it for there now. Okay, I promised you we'd spend most of our time on separation. So when I walk around a plant, and again, I did plant design for years, and I joke that, you have all these different parts, but no 2 plants are ever alike, and you put them together in different sequence depending what you're trying to do. So some of those puzzle pieces would be things like, an aspirator, perhaps. We can separate things by aerodynamic properties. Maybe almost everybody has a cleaner of some sort that's going to work with size and shape, as well as the, built-in aspirations. We're frequently doing a lot of sizing in the corn industry. For seed corn, the tower is frequently called a sizing tower because of the how dominant those machines may be in there. If you're dealing with a spherical product that's more like soybeans or rapeseed, perhaps we have spiral separators that would work on how well it rolls to separate shriveled from round. Gravity separators are very important for removing maybe low density seed that may not germinate so well, or other contaminants. And finally, of the common machines, we get into color variation, things that would be discolored that could be removed optically. And this is kind of an evolving software technology now, to where we're really frequently talking about optical sorting, where they're looking at shape or other factors. Okay, so just how do these pieces go together? Again, I told you no 2 plants are really the same, but this was just a flow for soybeans and small grain. So probably higher chance that some of you are doing the cereal grains there, in which case, perhaps we're coming in. We may have a deburger. I don't see those in all the plants, but it's basically some secondary threshing that goes on before the cleaner. The cleaner takes out most of the trash. Depending on what we're running, there's frequently machines that are somewhat industry specific, either an indent to remove differences in length, maybe on the cereal grains, or a spiral that might take out the oblong seed. there's various configurations you might have on a gravity table to separate by density. If the color sorter is there, it could be typically ahead of the treater, or sometimes I see it after the cleaner, particularly in a seed corn plant. The treater when it exists for a particular process, and some sort of packaging. Again, depends on market. Okay, a seed corn plant might look something more like this. The biggest difference here, I frequently see the color sorter after the cleaner, technically ahead of the sizers. They don't have to run all the individual sizes. Numbers of sizes and scope of these plants will definitely vary as well. But it looks something like this. The biggest difference in, again, that seed corn is almost always sized for U.S. markets anyway. Okay, so I work with some of the engineering students, and I like to explain that the difference here, but with seed cleaning compared to other forms of, say manufacturing that they may be working with, is frequently people talk about like 3D printing being an additive process, whereas something like machining is a subtractive process. And basically, if we're dealing with um, seed cleaning, I mentioned that we have different machines that are separating things, and we're basically removing stuff from it. So it's a subtractive process, and we're basically carving away at this thing, by removing everything that we can blow away and everything that's too big and small, and then maybe things that are the wrong density or things that are the wrong color, until we hopefully try to remove everything that's not desirable from the seed that we want. And typically we'll have to use more than one machine to get there, unless we're just separating, I don't know, golf balls from seed or something. So what are we removing? And I suspect most people on here, could give me this list, but we're after the foreign material, weed seeds, other crops, mechanical damage. We'd prefer not to break it. Varietal contamination is very difficult to remove. And then we get into, when we start talking about upgrading, removing low quality seed, why is it bad? Is typically either seed physiology, which or different pathogens that we may have that would affect it. Okay. Now, I talked about how we're carving away at things, and we frequently seem to get into various histograms, different bell-shaped curves. And this was a box I actually built as an undergraduate, and the students found two of them back a while back. And we used these before we had bar graphs and computers and so forth. And you would basically drop things through a series of hand screens, and then pour each hand screen content into one of these, and it generated a graph that we could use for teaching. And you can see that we get this bell-shaped curve on here again. And those of you who've ever worked with screen selection know that you're trying to pick the screens to trim the tails of that bell-shaped curve as much as possible without losing good seed. So, it's interesting at least to talk about that. And as we start talking about things like a gravity separator, you're looking at a density curve that you're trying to trim. On color sorters, you're literally seeing this type of probability information, sometimes shown graphically, and that's sometimes how it's set. So we're basically going through a sequence of machines, trimming each curve as far as we can before you lose too much good seed, and then back off a bit. And then at the end, if there's still defects, we have to decide what machine would be the best for removing that defect and go make the appropriate adjustments. Okay. Again, when we're talking about separation efficiency, any theoretical process that we might have here, a simple one perhaps just has, product and discard, good seed, and they're rarely ever 100% efficient. So when we're talking about it, it's kind of like a batting average, but what percentage of the defects did we get? Typically, we won't get all of them. But we can also deal with recovery of good product, because one way we can get most of the defects is to throw a whole bunch of good seed away, but the economics of that are not good either. So, what's the yield? And I like to say that seed plants are typically between the proverbial rock and a hard place, where quality control wants to remove all the contaminants, and the accounting people want them to keep every good seed. And those are kind of conflicting results, plus, especially when you need it all done quickly by schedule and within budget. We get into some things with separation efficiency. I'm going to stay off most of that today, but just keep in mind that getting complete contaminant removal typically means you have to remove at least a small amount of good product. Okay, here was just a hypothetical graph. This is not real data. It's just something I made in a hotel room at 11 o'clock at night to explain the idea. But if I'm adjusting some machine, maybe it's an aspirator, and removal deficiency levels are usually given from 0 to 1. The idea was that if I turn up that aspirator, I can throw more and more defects away. I may not get all of them, but I probably don't want to run clear to the right, because if I look at my yield of good seed, I'm starting to throw good seed away as I crank up that air. And so again, there's a way to combine that, but that curve varies a lot depending on application. So if you can keep in mind, we're talking about yield, it's what percentage of the good seed we kept, and we're talking about, defect removal or efficiencies type thing. It's usually just, how much of a particular defect that we got out. Okay, a seed plant's usually going to try to run somewhere in that range. And a lot of this is really done by experience for a particular application. Okay, I'd like to talk, again, we're dealing with a lot of equipment operators, and so about, different tools. Why do we have the different tools for it? And I mentioned that this is somewhat of a subtractive process. And so much like wood carving, you're carving away at and removing things. And so, sometimes at a state fair or something, you'll see this guy with a chainsaw who's making stuff, and he has 10 minutes total to do it in one tool. But if you have more precise tools, you can get better details. And a good operator that understands the capability of those tools and how and when to use them can provide superior results. This statue happens to be just outside seed science. It's George Washington Carver. And I've got a series of slides here. We're going to talk about different tools, 4 of them, then I'm going to give you examples on each one as we go through. But perhaps we can come in here and we have an aspirator. Okay, humans have probably been blowing light product, wheat from chaff or something for longer than almost anything. But in this case, we're looking at either usually an inclined or a vertical column, and just a difference in how fast that seed will fall through the airstream. Okay, a cleaner combines that again with some perforated screens, and typically we'll blow some trash away at the beginning, and then clean things to remove, too large and too small, basically to scalp and sift the product, and then finish with a second aspiration that's more precise in order to get more of the low quality seeds away. Sometimes that's the only machine needed for simple applications, but other times it's just the beginning of the process. The cleaner almost always takes the bulk of the contaminant out. Okay, aspirators come in a lot of different form factors. I see quite a few of these multiple pass ones around the Midwest just for kind of pre-cleaning. Those of you who may be involved in something like a disc-shaped seed like tomato or pepper, I see these more out in California. So it's something that Peter Marks will have seen probably more often. But they're just different configurations of the same notion depending what they're trying to accomplish. Okay, one problem with just aspirating is that you don't get big heavy things. Let's say I have sticks or corn cobs or something in here. Then I have, they may not blow away because they're actually heavier than seed, or a stick may stand upright and fall down through the column of air. So one simple way that was done to get things that are grossly larger, quite a bit bigger than the seed itself, was a scalping reel. And this basically is just a rotating wire reel, and the seed's being poured through this thing from the top while it rotates slowly and conveys the large product like corn cobs or stalks or something off the top. It's just a rough desticking type process, but that combination helps substantially. They used to be in all the corn plants. I see them a lot in soybean facilities now for removing pods that would give them trouble otherwise. Okay, then here's an old diagram of a small cleaner. Usually there's at least 2 screens just to remove things that are, again, too small or too big, and some small machines here with just different examples of things that would be done to remove some of those contaminants. And the components of it, again, we've mentioned that there's usually an upper air or some form of a pre-aspiration to get the light trash. There's the scalping screens that are the oversized product. Different sifting or grading screens, again, undersized, and then finishing up in an aspiration. Okay. Okay. What comes out? Again, this was an example here with soybeans. Again, you can see kind of the light trash that was blown away to begin with. I frequently have students asking me why, these pods didn't blow away. And up here. And that's basically because there's seed in them. They're heavy enough that they wouldn't blow away easily. We've got, undersized material, which are usually splits or weed seeds on a dicot like soybeans. Things that we can blow away, again, low quality. And there's still a split here. There's some merit to some additional equipment, as we'll see here a little bit later. Okay, seed corn, it would look something more like that. Again, those heavy corn cobs and stalks and so forth came away on a scalping screen. And just for fun, I threw some flax in here. There happens to be some cereal grains, a contaminant left from the combine, probably, that we were removing as just due to different size differences and so forth. Okay, a few examples of some cleaners. In a seed plant here in the Midwest, these may be something resembling the one in the middle, and it's maybe 2 stories tall. But you get into some smaller vegetable plants. This one happens to be on the West Coast, and some other different variations of what are really lab cleaners, but sometimes they're the primary cleaner for um, a small facility. If you're particularly people doing the high value seeds. Um, Okay, when we're dealing with a cleaner, we can have basically round hole screens or slotted screens in different dimensions, English or metric as well. These happen to be the English dimensions. But when you deal with something like soybeans, split removal is the big thing. And so they'll work with whether the slot is parallel to the slope or 90 degrees perpendicular to the slope as a cross slot. And we have kind of a hybrid as well you find in some soybean plants called a herringbone slot. That's really about the cross slot removes splits more efficiently, but doesn't get sticks so well. The parallel slot is there for the sticks, and usually you see a mix of the two. Any of you, heard that there may be some folks doing turf grass. You get into small seeds, frequently you may see a wire mesh of either a square or a rectangular mesh of so many wires per inch. And in the cereal grains and a few other things, there can be triangular hole screens removing things like basically triangular weed seeds, but wild buckwheat or wild morning glory perhaps may come out on something like that. Again, we'll have a mix of different types of screens depending on what the application may be. Okay. Again, what we're doing when we're doing hand screen selection here is running it through a stack. Perhaps we know something about one end or the other, and so we can basically figure out where to trim the tail on that bell-shaped curve. I like to use various types of mechanical screen shakers. This is bigger than you would probably need. It'll handle up to 28 screens because of the seed corn applications we get into. But again, trying to remove as much bad and keep the good. Okay, now we start moving into things that would separate by various dimensions, perhaps more precisely than we could with screens. And in this case, we have the things that separate by length, which would be an indent or a disc separator. Basically, short seed fits into a pocket and long seed doesn't. And as it spins around, it can pick more of that out. Again, cereal grains are the most common applications, but desticking other crops can be important. I've mentioned seed corn sizing. Sunflowers are frequently sized with things that look more like this, which is, again, a rotating cylinder with, in this case, contoured holes to help present that seed to the opening and drop it through there, hopefully more consistently. And so 2 different machines with different applications here. The main difference on the sizing is just the shape of the hole that came in here. And okay, so when we're dealing with length, again, it's a short seed and it fits in the pocket and gets lifted. The long seed just keeps tumbling as it works its way down through the length of the machine. A few of you may be familiar with disc separators. I see them more often in high capacity wheat or rice seed plants. But in this case, the idea is still the same, that we have a short seed fitting in a pocket. The short seed is the pockets are now cast into the sides of a rotating disc. And there's a bunch of these discs, maybe 27 of them, 25-inch in diameter or something down through the machine. And as they spin, they lift the short seed away and it gets tossed out the top basically by centrifugal force. Either one of these is lifting short from long. They're very common for any kind of elongated seed where length becomes important, where perhaps you can't actually see the difference, the width and the thickness may be the same, so a screen can't actually separate them. Length becomes important for those types of applications. Some of you may be familiar with some of the European brands that use an offset indent. In this case, that pocket has been kind of deformed to one side. They're basically trying to mimic some of the effect that we can get with a disc. And in this case, here's just an example of one particular brand, but the same concepts exist. It's just that offset pocket kind of helps lift maybe an elongated seed like many of the grasses or cereal grains that they would be cleaning over there. The folks that are desticking might worry about reversing cylinders and other things. Okay, here's just one fun application. This came into one of our color sorter workshops, and they wanted to get these dark seeds out of here. There were some weed seeds inside it that needed to be removed from the white lettuce that they had. And we had a double of a time getting it sorted by color, but we wound up with something like this. And the way I did it was to take the sample and run it through a small indent. And we got something that very much resembled a color separation. One of the fun parts here is some of those weed seeds were actually the bodies of dead insects. They were just missing their wings. It wouldn't fall down the chute. We'll talk a little bit more about that on the color sorter later. Okay, just a little bit on disc separators, probably not a common thing there, but the pockets do come in different configurations. I certainly wouldn't worry about all the different designations there, but basically there's V pockets that'll tend to lift spherical things. The name comes from vetch. R pockets that tend to lift cylindrical things. The name there again comes from the um, uh, from rice. And then the square pockets are usually what's desticking sunflowers and other products. Here's just a quick example of that. You can see where they're basically lifting the sunflower, and you can see the sunflower seeds flying through the air here. One advantage of an indent or a disc separator over an indent is that it has a lot more pockets, okay? And if you have to physically lift every seed, you're not going to get a seed in every pocket. So the more pockets you have, the more capacity you can get. And if you're physically lifting all the seed away from sticks, you start to see the discs are very big indents. The indent has a better advantage from a standpoint of adjustment. Okay, you can change the speed and change how much is being lifted. So sometimes I see a mixture of the two machines for specific applications. Okay, then we move into width and thickness. Again, this is done with a precision sizer. Either the round holes tend to separate by width. If you think of how a seed would be presented to an opening, if I had a round opening, and this is my seed here, basically a round opening, if you think of a manhole falling into it, it tends to see the width of that seed. A slot tends to see the thickness. Okay, it's going to fall down through that slot. Neither one of these tends to do length. That's what the previous machine was for. So in this case, we have, again, seed being presented to that round opening for separating by width, or to a slot for separating by thickness. And then we'll typically have multiple machines in order to get the desired results. Okay, we have a small sizing stack in my lab as well as a two-cylinder machine, but this is just a series of 4 single-cylinder machines that look something more like this. The sizes vary because we can change them much like you would cleaner screens, but in this case, producing 4 sizes and an undersized discard. And I want to point out that depending on how many sizes we need, if it's sunflowers, perhaps they're 5 and they're all done with round or so, but we'll need multiple machines because every machine is much like a screen or a cylinder. It produces overs and throughs. So I only have 2 sizes. If I need more, then I have to have a few more machines, okay? The number of cylinders at each point depends on capacity. This small line here is based on single cylinder machines, but you can find machines with 2, 4, and 6. And then beyond that, we put more machines in parallel. And there's some complications. You get into balancing a sizer stack. I'll just briefly introduce it here, but you get beyond the scope of this presentation. It can be a couple hours in a workshop just to talk about sizing efficiency and how to get consistent results from that. These types of things become important elsewhere in the process. Having consistent sizing not only helps planting, but it makes differences on your treating results and so forth as well. Much like removing all the foreign material becomes important. So right here, I've mentioned that a sizing tower in the Midwest contains an awful lot of sizing equipment. Here's a shot in one of the larger, of one floor in a large seed corn facility here. So they do have a few cylinders, and selecting those cylinders beforehand becomes important. So you don't install them all and then find out you're wrong and you've got to start changing things. So how do we do that? Again, it's much like picking screens. It can be done with flat screens. Typically, I'll see people get an overall distribution with the screens, and then decide again what to put in the cleaner and for the undersize removal. And then the tougher part is picking where you're going to split the sizes. So typically they'll split the width separation first, perhaps, and then the thickness, but that can be done in reverse. It's possible to verify those results with a laboratory batch sizer, or other methods. There's some optical equipment that's being experimented with as well. This is a little bit less clear cut than just the cleaner. Okay, on the cleaner, we know that we're trying to remove the bad and keep the good. In this case of sizing, it's just a question of how we're sizing the good. Okay, so what are we going to call large, medium, and small, flat and round? And so there's a little latitude on that. Sometimes that varies on the end use, how much variability we can have for plantability. I'm starting to see discussion on variability for seed treatment, and sometimes it's purely marketing requirements, but we'll see a different number of different things. Again, here's the batch sizer I talked about. We use this for some lab things and for doing small batches and so forth, small lots that we might run into. Again, overs and throughs. So one disadvantage, if I need to make 4 or 5 sizes, I've got to run through this a few times. But it's perhaps easier than trying to fire up the whole tower and losing the lot in there someplace. Okay, I mentioned that there's issues related to balancing sizers. And so one of the problems we run into is not only that the capacity of a round and a slot are different. Okay, the round has more capacity than the slot, as you can see here. This purple up on top is basically the round hole in capacities in bushels per hour. But the other problem is it also varies depending on how much falls through. Okay, so the rated capacity of a sizer is based on 95% falling through. So basically that means 5% are going over the top of the cylinder and heading in with the other product. We're basically wrong 5% of the time. But if I push it too fast, more product carries over the top. If I slow down, I'll get a little higher efficiency. So if you see here, as they're rating it on 95% and then saying that's the capacity that the manufacturer says you can get from it. Your results may vary in a real plant, and it also varies on percent throughs. So if you think of the difference between a scalping and a sifting screen, if you have almost everything falling through, which would be scalping, the bulk of the product goes away right away, and there's more time for it to work its way down through the cylinder and search through the remaining product for the undersized material. But if only a small percent falls through, much like it would on a sifting screen in a cleaner, there's an awful lot more product on that screen, and you're going to have to slow down to give it time to find the remaining undersized product. Again, so the complication here has to do with keeping everything working at a reasonable efficiency. If you overload one of these machines, that efficiency may not be 95%. I've seen times when students are running it and it was 60%, which means 40% of the product that's in the overs is actually throughs, and quality control is not happy. So balancing that and we even do this in an agronomy class where we look at what it takes to predict the sizes and then what it takes to evaluate what's there and how to get those two numbers to match. Okay, sometimes what's old is new again. If you went back several decades, you'd find seed corn plants would have something called a rocket grader. It was flat screens and kind of a rocking motion and contoured screens that were used for sizing corn. And mostly we see the rotary cylinders because they were more efficient at the sizes for these large seeds. But I do see people now adapting flat screen cleaners for sizing. It's fairly popular due to some concerns on mechanical damage with the rotating sizers. You do have to slow these down. Typically, you start at half capacity of what it would be for a cleaner and then go from there in order to try to get acceptable efficiency. But we do see both of those methods being used pretty heavily through there. Okay. I mentioned that soybeans, are the other alternative here in Iowa, and but this same type of machine can be used for almost any spherical type separation. I've actually used them for separating round fertilizer pellets from grass seed before and some things. So if the difference is, if one of the two products is roughly spherical, we may be able to get it with either a spiral or a belt. The belt has a series of helical flights, and the seeds being run down by gravity. And basically much like running on a curve on the highway, if you drive around it too fast, you'll fly off. The round seed basically tends to fly off the spiral separator flights, while the less round product stays on it. And the belt is basically an incline belt. It's sloped in one or two directions, and the product basically rolls across it to make the separation. Okay. Those of you not familiar with soybeans, these are some of the reasons we may be concerned about shriveled or oblong seed. Again, typically physiological problems, some pathogens as well, that would cause it to not be a nice plump round seed. And perhaps we can separate it by how well it'll roll. You can get some of this by air. You can get some with a slotted screen or other things, but typically, the shape sort here is important, and you'll see some optical shape that's also developing further, but sometimes we see this able to do things we can't do with the optical sorting yet. Okay, so just a couple examples here. These are different numbers of cores depending on capacity, 1, 2, or 4. And then I see multiple machines. I've been in some large soybean plants that had 48 cores, but we also see them used for small lots, laboratory samples and so forth. And for just selecting the right geometry for that core can be important. Now, the classic problem that I hear from plant operators is their spiral doesn't have enough adjustment. Okay, it's always throwing away too much or too little. And so one thing that we're seeing people working with are rotary spirals. This idea is pretty simple. It's just basically spinning the core with a small motor, and that basically is used just to adjust the separation. We can change the amount that's being saved or thrown away. A 4-core just has one motor and a timing belt inside there to do this. And just a quick example here. This is one of the 2 rotaries in our lab. And agronomy lab this fall, we did a virtual lab for the students due to COVID-19. And so I had some footage and so forth of this, but these are the 4 different speeds that we ran the same basically samples through, and kind of almost a visual bar graph. This is at different speeds. This is basically the round and the flat. And then as we shifted, we threw less and less, more and more round out basically, and got to a smaller amount of flat. And then this was the product off of those. So you can see the effect of just changing the speed, and dramatically difference in the quality of the discards here. This definitely throwing away too much on first of these, but getting down to a more reasonable amount here. And then I happen to have the images from an optical imaging counter that we use sometimes for evaluating it. Sometimes you wind up having to measure seeds or try to quantify them visually or other things. This can take a picture of it and give us some numbers very fast. Again, this isn't a replicated trial. It was just things from that agronomy lab, but basically the round seed off of the 30 RPM, the one that had the smallest amount thrown away, that's probably the closest to a realistic separation. That basically was our good seed, and this was our bad. So, we're getting corn, we're getting other things. We're getting what almost looks like a color sort, but it's really based on shape and how well it'll roll. So again, interesting idea on what something like that could be adjusted to do. Again, I'm going to back up here. The idea of trimming that bell-shaped curve, if we can, you can adjust that easily with one knob, basically move the speed up and down until you throw away as much bad and you start to see too much good in there and you back off a bit. Okay. When I work with the food grade soybean people, I see a lot of belt separators for export to Japan. But in simplest form, it's just this draper belt that's down here at the bottom is a single slope. The seeds put in the middle. The belt is running up the hill. The round seeds basically roll down the hill, and the less round ones go over the top. I sometimes say that this is much like trying to run down an up escalator. If you're in good shape, you can run down the escalator. If you're not in good shape, it'll take you over the top. Okay. Most of the newer ones I see are sloped 2 directions, and you'll see that on the next slide as well. But the idea here is that the seed, basically the round stuff, can run across the belt. The belt is running here towards the right. The round product comes down, the flat product comes over, and sometimes we can make some intermediate fractions as well. The large machines for food grade beans are basically multiple belts in parallel. That's really just about capacity. Okay, few samples. This is a small single belt unit that we have running some soybeans. At this point, it was still on a running gear outside. It's in the facility now, but this is one waste basket full of soybean and the output from it. Okay, so you can see there's a small amount of flat and oblong, and then progressively more as we get into this. So the round is obviously the good. Oblong is probably going to be good for most applications, other than the Japanese assure me they don't taste as well. The discard, would be something like this. So, there could be a debate on something along that line, but most people are definitely going to discard those, the splits that we'd have down in here. These two, sometimes I see a valve or something so the operator can quickly make a decision on those. It's a more precise separation than the spiral, but it's larger and more expensive and less capacity. Okay, then as we start dealing with things that would be used for upgrading seed, these two work on completely different principles, but we'll see gravity separators and color sorters. We have 7 gravities in our facility and 3 color sorters now, but more that come and visit us during the summer. So there's a lot of interest in what can be done for those types of things. These are both finishing machines. They are normally toward the end of the line. They should never really be ahead of your cleaner. But it's some things that we're going to get into on it. We're at is there a, I got the chat window off here right now. Are there any questions? Maybe anyone that him or somebody's got questions that I should deal with here before we give you just a short break. Here's the chat. Okay, I don't have any. Does anyone have any questions? We just take a break here while I grab some coffee and we'll continue.
Sure. Obviously Alan is, has tremendous depth of information as well as experience with a lot of different cropping systems as well as just all this different type of equipment. So if you have something in your own particular seed company, sorting questions, he's the one to ask. So please feel free to jump in here while he at least has a chance to rest his vocal cords. Let me just jump in, and this is more of a grain question. You know, hemp is a big thing for us here at Cornell, and so we have an impact hauler, which would be a small commercial scale, and again, is to get the hemp hearts out, which would be used as a food type of a situation. So since hemp grain and hemp seed are about the same, so I got involved in what equipment to use and things like that, which we've already purchased a year or so ago. The first thing, and even with hemp seed, the seed companies are not doing a very good job at all of sizing the seed. So we're getting a fair range there. So I feel like one of the first steps I need to do is to go ahead and to get the size. But the main piece of equipment is the impact hauler. So we're using a Fosberg unit, which would be one of their smaller commercial size. So our challenge is, you know, hemp is a oil seed with like 35% oil seed. So you can run this stuff and all of a sudden you're kind of just making an oil seed cake inside of the hauler. So I think we just need to be very careful how fast we're running this thing and things like that, or else, like I said, is the seeds, I don't know how close they would be to like a baby soybean or say, but it's a very high oil. And when that you fracture off that pericarp's just like a sunflower, basically very hard, that these things can get, you know, really just impacted inside of the impact hauler. So I know you don't work with hemp there. I know I was been slow in getting into the whole hemp thing, but you kind of see the grain seed situation that we're dealing with in this.
Okay. Right. Two things there. I do wind up with a lot of products that have dual use, and some summers, about 30% of the people at the workshops are actually doing a food grade product of some sort, but they happen to use much the same equipment.
Right.
As you indicated, hemp has been kind of a problem here for me because up until very recently, we couldn't legally bring the stuff to Iowa. You could get into trouble, and I'd run a blind question off to the regulatory people and get an email back in big capital letters that under no way should I bring it to Iowa State. So we didn't have, you know, a write up in the Des Moines Register or something over it. But so I can't speak directly to a lot of experience with it. Sometimes we had to physically take machines across state lines in order to run a test. And the hulling, I've done dehulling on other things when we get into some of the nut crops and so forth. How tough that hull is a huge difference between different seeds. Dehulling soybeans just requires a handling system typically, but something like this so if you start breaking seeds, we've been into some things for food grade application, dehulling cottonseed, which is brutal. Some other spelt or something might be an issue as well, but usually I wind up trying to take a light pass and then recirculate the product back through somehow. So there may be some opportunities on that. We perhaps can discuss that later, and maybe there's some things we can look at to help resolve that problem. I don't have a lot of dehulling equipment, but there's some elsewhere on campus as well that we can get to, and other potential applications.
Okay. All right. Fair enough.
Okay.
Anybody else have a question they'd like to bring up at this time to Alan? Or you can put it on the chat. Just go ahead and type in anything at this point.
Alan, this is Garrett Coleman. Had a quick question. This summer when we were running wheat, and you're going to get into gravity tables, but I was showing one of the guys that works for us the difference in test weight going across the gravity weight table from light to dense, and I was using one of the handheld moisture tests that has a test weight. And from the light side, it was almost a point moisture difference to the wet side. It was going from like 11.5 to like 12.7 or 12.8. I guess it was over a point. Is that pretty common?
It's deceiving. Okay. You said this is a handheld moisture meter. Okay. So you maybe pre-weigh a sample, or you're just pouring it into a cup and filling it to a certain point. Okay. that meter is based on capacitance. Okay, the capacitance of seed. It turns out that it can be correlated with density and it can correlate with moisture. If you mix both of them together, it's a problem. As an undergrad years ago, we managed to prove that we could run wet corn, 25% moisture corn across a gravity, and the different fractions would read anywhere from 14% to 40 off the same lot that was supposed to be 25. The air oven samples came back and they were all basically within 1%, plus minus one. But so we were basically fooling the moisture meter because the density differences. Moisture meters are not typically calibrated on, at least in the 80s, we're not calibrated on density. And I've got an idea your machine can be fooled by the density variation. It's much more likely that that you're really seeing a density difference, but it's being reflected in the moisture meter readings as well, since it's not compensating for that. You will typically see a difference in density. What we're usually looking for here, and we'll talk about more curves, but the idea is that, if I can get this right here, is that we have a lower density product, toward the light end. It's kind of an incline perhaps, and then to a more of a plateau with the higher density. And we're trying to frequently remove the product that's low density, maybe recirculate or do something else with that intermediate product, and then hopefully keep the good. And maybe we have to remove stones or something as well off the heavy fraction. But yeah, density is one of the big things when you're talking about gravities. I see people frequently looking at things just visually, but sometimes you'll miss stuff that way if you don't see the density difference. I've got a couple examples we'll use to do that. Likewise, if we don't have time, if you don't get a question in here, my email was at the beginning and it'll be at the end of this presentation as well. So you're always welcome to email me things as well, and we can help deal with it. Gravities and color sorters seem to be something I talk about a lot. The students joke sometimes that you could wind up the key in my back and I'll start mechanically telling you about gravities and color sorters. So an important topic in the business. Other questions?
Alan, probably we'll just let you get back into your presentation too. But again, start thinking about these questions. And again, you can see the tremendous amount of experience. And like I said, what you think is, oh, well, we have a moisture gradient. Well, it's like I said, it's confounded with the density of the product. So that's really, really neat insight there. So thank you.
After we did those tests in the 80s, I was working with Dr. Charles Herberg at Iowa State at the time, and there's some more history there. But let's just say later on, the moisture meters came out that would take, when the moisture meters started taking test weight, it's because they're attempting to compensate for the effect of density differences on that. And we basically just showed how aggravated it could be when we were playing with it. So anyway, back to the gravities and color sorters, things that are upgrading it. And it depends a little bit on, I frequently see people thinking that these are somehow interchangeable because maybe they see the same defect coming out in either one. And it depends on what the problem was, back to physiology and pathology. Does it affect the density? Does it affect the color? Maybe it affects both. If it affects both, we might be able to get them with either one. But sometimes density is more important, or color can be. Color, if I've got purple stain on soybeans, I really can only get it with the color. But there's times when low density seed comes out. Unfortunately, if it's only low density, humans aren't very good at seeing that. So I get into this argument. We have an ongoing debate in the Midwest on, do we replace the gravity with a color sorter and things? And that might make some sense in soybean, but surely that wheat example you had would probably be the wrong choice for that. Okay. Okay, then, so if we start talking about gravity separators and destoners, both separate with a fluidized bed to kind of differentiate it from an aspirator that might blow the low density away. In this case, we're going to float a layer of fluidized product across and basically float the light from the heavy. A destoner, as the name implies, basically removes the heavy product, stones, soil pads, lumps of dirt or other things that might be in there. Whereas the gravity provides more of a continuous range from light to heavy, and we get into this decision on where we're going to cut and try to keep and throw away. We start talking about density. Everything we've talked about here so far is bulk density. It's test weight. That's done with a test weight apparatus, but then the moisture meters are actually calibrated against something like this in order to give you that number. The bulk density does kind of, since you're just filling a volume like a pint or a quart cup, For setting a gravity, I've actually used coffee cans and weighed them if we didn't have anything else available. But particle density tries to remove the void spaces. What's the density of the seed itself? It's a little harder to measure, and actually a little less useful in most seed applications. We use it more for research, and we're trying to determine what's, because you can do it on individual seeds if necessary, and you can remove the size and shape effects. And there's a term called specific gravity. I bring it up here. It's really the particle or the seed density relative to water. It's just a number that's greater than or less than 1. If it's greater than 1, which is most seeds, it'll sink in water. If it's less than 1, it'll float. If it was 1, it's the same density as water. But it's interesting because the term gravity table or gravity separator actually comes from the term specific gravity. However, on large seeds, the density separation is really more of a weight separation. It comes closer to that than it does to specific gravity. Okay, how does this thing work? Some of you are very familiar with it. You know that you shouldn't have it boiling on the deck and so forth, but not physically boiling, just bubbling. But basically, if I have a little hypothetical bin full of seed here with some airflow straighteners and a fan that can deliver any amount of air I need. If I turn on that fan low, maybe I can dry it or aerate it, but I'm not going to separate anything, maybe some hulls. I'm after a Goldilocks point here. We want the point where there's enough air that it starts to basically become buoyant. It'll start to lift and fluidize the product, make it act like a liquid. At that point, the heavy product sinks to the bottom, and those heavy particles displace the light ones and cause a vertical stratification. We've got to get this to happen before we can get the separation. Some air is good, but more is not better. If I put too much, it's going to tend to bubble and basically mix this whole fluidized layer together, and I lose the stratification. That's why they always tell the operators not to use too much air. The other problem with excessive air is it tends to lift the seed away from the deck, and you lose friction with the deck, and it's harder to get the seed to climb up the hill. I also want to point out that this type of a separation depends on the interaction between those two particles. So there's no way to gravity separate one seed by this method. And it has an effect on small lots. So sometimes you don't have enough product to cover the deck. And so, we have an assortment of different sizes of gravities for some of that same reason, but other times you physically can't get down to that small amount. Quick idea on a destoner, and again, it's the single slope compared to a dual slope system, much like I saw on belts. But the idea here is that we have maybe a wire mesh reciprocating deck, and it's shaking in such a way that it will tend to move the seed. Whatever's touching the deck will tend to move up the hill. If I put seed on at least 3 seeds deep, but maybe more depending on the application and the machine, and I bring airflow through there perpendicular to the deck, and I basically stratify this. Okay, I get that right amount of airflow. I magically get the Goldilocks point of, where I can stratify the product. The lights on top, the heavies are on the bottom, and they're touching the deck. They get conveyed up the hill. And the lights basically float downhill, much like a sled on a snowy hill or something that you might have, and they're just floating downward. And so they're a bit counterintuitive, and the heavy things go up and light things go down. I've had students look at me because they're sure I lost my marbles or something through. And in this case, I didn't completely remove all doubt, perhaps. But a gravity is going to look much the same, except that now I introduce another slope. This was the second of 3 Olivers that have been in our plant. But the idea that we're going to be bringing this product, across here. This is the top view. The highest corner is here. So the slope that you saw over here on this cross section is vertically through this diagram. Okay, so as it's shaking, it's tending to take the heavies and move them up the hill. As we put product on, there's about maybe a 2-degree slope along the length. And so as this shakes, it just sort of walks it down. A fluidized product has a relatively low angular repose, and so it'll gradually travel down the length of this. If I increase that slope, it'll travel down faster. The net result is that I get a range here again from light to heavy, and then I'm setting these gates perhaps to try to decide what to keep and what to throw away. Okay, there's our slope. This was some really bad soybeans that were rejected for an organic seed lot for Japan. But you can see the dark colored seed in here. In this case, I was pushing that machine really too fast, but you can kind of see a curve that shows up. That curve really should come down more like this and follow this part. But you can kind of see where we stratify it and we're moving this product down. I'll show you that a little bit more on some Bromegrass. But I want to point out that this separation is not purely based on density. If everything was the same size and shape, it basically would be. But if it varied, if maybe it's made out of plastic, it's candy corn or plastic soybeans or something, then basically the large seeds will sink to the bottom and displace the small ones, and you'll get a size separation. If there's a shape difference like we have on corn where you could have flat or plump round seeds, the plump ones will tend to go to the deck and displace the others. If you mix that together, the separation is tough to predict. Sometimes you can get a usable separation, but this is one reason that the seed corn company's size product, in addition to plantability, is that it does gravity separate better with at least a few sizes. Okay, promised you a Bromegrass slide. This is an older one with a cloth deck running a native prairie grass basically across. So there's a stratification zone. You can kind of see the colors on this perhaps, but we've got to stratify it. Once it's been stratified, the lights will start to go down. And then again, this is a large difference in density. So you can see it come down pretty quickly and then follow the light edge. I have progressively heavier product coming out. I was also taking some product off the stone trap here. So we had some waste baskets of product here, and I shot this picture. These are not stones. These are actually product that has been excessively brushed. Okay, when this product came through, it had some secondary threshing going on. It would be rubbed against a brushing machine, and if you took the remove the pericarp, basically you have just the caryopsis left. The kernel inside is what you have here. And then basically light hulls. And it was interesting that these hulls were actually aspirated several times before they got to the gravity, and we still had not removed them. The gravity takes them out pretty easily. Just a quick example here of what those look like. Here's those light hulls. Only about 4% of these are even filled, but a gravity, it's tough for something to stay standing vertically. It'll fall over, and then I could separate it, whereas it might fall this way through the aspiration. And again, you can see the heavy ones that were excessively brushed. They're only about 0.3%. They're a lot heavier in terms of test weight than my hulls would be. So there was an obvious solution to take the choice to remove these. You start to get into some debatable issues on the rest of this. Okay, couple historical diagrams here on why we use gravities in soybeans and corn. Some of that same project I showed you for the mechanical damage concluded that the biggest single difference in germination improvement for the soybeans was the gravity table. In corn, this was probably some 70s era material, but there's some light product. And if you could remove this, you could basically raise the average germination, the balance of the lot. This is kind of a numbers game because these are not all dead. In this case, they were 76%, but if what you could remove would slightly improve the germination of something like this. The numbers are more dramatic when you get into some of the vegetable seeds. Here is some onion seed, and this is upgrading onions, okay? When you first run onion seed through it, you get a lot of foreign material that comes out. But if the germination's not good enough, oops, we've got to run it back over the gravity and cut some more. And maybe we cut 20 or 30% in order to get something that's marketable because the germination is just not high enough. I see the same thing on carrots and some other vegetables, but there's no real color difference here. But if you look, and this is just done with a little toy gravity practically, it's not even a very good separation, but my light is more like 23% versus 64. A big gravity, I probably would have gotten at least a little bit of product here off the, about 80%. This is just blowing that up, looking at it closer. Again, very little visual difference, but definitely a density difference. And here's just a quick shot of some the roll towels, basically looking at the germination sample for the light versus the heavy product here. Again, the numbers weren't dramatic, but it can see a difference the density would make in viability. Okay, here's another one that was interesting, not replicated, but I have some really nice looking sweet corn that came through, and we gravity separated it and separated it by density, measured the density differences on this curve that we talked about. And oops, I realized I had 25% of the product I'd removed. So we did some things and made it into 5 and then blended them back. A miracle kind of occurred and we came back, but got it back to 3 fractions. And then I thought it'd be interesting to show you the results from the germination trays. So basically from light to heavy, this was about 54%. This is about 94, 95. And there's a difference in vigor as well on it. Now, I'm going to warn you that sweet corn and yellow dent are certainly not the same. Sweet corn tends to have more problems, but we had tried colored sorting this. There really was very little visual difference to be had, but a big difference for density. Okay, sometimes contaminants might come out. We had a cereal grain question here on wheat. We frequently see ergot in wheat or barley or rye was the classic problem with ergot. don't have a lot of time to get into it today, but in food grade products, Google ergotism, and you'll find some interesting things. It's a bad idea to have this stuff in feed and food. Okay. And this was looking at separating ergot by density. And we were looking at, in this case, they were looking at different lots, and basically what it came out after the cleaner is the blue and the percent ergot. And the red is the gravity heavy, which it did not get to 0, but it removed the bulk of it. The gravity lights have a lot of ergot, so don't feed that to your neighbor's horse, something to that effect. But we've done it can be very, very effective at removing that. Again, sometimes when we're getting things like ergot, or if we have some of the mycotoxins, perhaps aflatoxin in corn or peanut, if you get into vomitoxin, perhaps, you have to be a little careful. If the overall lot was not safe for feed and food, and now we concentrate it, it can be substantially worse. We see that even aggravated if it's corn going to an ethanol plant, because the fumonigens don't go away. They just get basically tripled as far as the percentage level once the starch goes away. So other diseases on corn, this was just showing the effect of sizing and gravity separating. So basically I have 4 sizes here, and then gravity lights, mediums, and heavies. And we'll cut to the chase here, but in this research, they found that on that particular lot that they were working with, they were getting about 3.2% of the seed in that particular size in the lights for the small round, but it was about 40% of the infected seed for Fusarium. So it kind of shows you this advantage of sizing and density separation together. Okay, when you start talking about gravities, you'll see different shapes. I mentioned that there's 7 different machines with triangular and trapezoidal and rectangular decks in our lab. They have different purposes, but I have to teach people how to run this assortment of different machines. The first thing we look for is which way is the shake going. If you overlay the trapezoidal machine like this one with the rectangular so that the deck motion is in the same direction, it's much easier to understand what's going on. So perhaps we have a rectangular deck like the one I've been showing you. It's this sort of a shape. The conventional wisdom is that provides a longer travel path for the light seed and does a more efficient job of separating the light, which is usually what we're trying to remove if we're trying to just get like on a lot of the field crops or other things. If we're after the heavy product, sometimes we see the trapezoidals. These used to be very common for corn for some historical reasons as well, but longer travel path for the heavy. Again, I see them a lot in the vegetable plants yet, where they're trying to they're trying to salvage some product from a lot that's perhaps inadequate otherwise. Okay, here's an old video, 1988, showing the first Oliver that was in our lab running. And you'll see some product again coming in from the top here, the inlet stratifies. You can kind of see the lights coming down over here, and then a range from the light up to the heavier product as this migrates down through the deck. If I get Brian Fisher, I believe, through that, that's actually a nightshade berry, but we do the same type of thing today with a roasted coffee bean. But they'll take off and they'll just float down here. You can see the lights work its way. The reason that's blinking is not your system. It's a very short video in a loop. So in case you hadn't seen one of those run. Okay, now we do all the things to try to adjust it. We have full day, or now we were trying to do a 2-day workshop on gravities this year before COVID came around. But once you separate it, there's sometimes the efficiency isn't good enough. We know that if we have a range from light to heavy, that if this is good and that's bad, somewhere in the middle is intermediate, mediocre product. And so it's a question if that's a mix of good and bad, or if it's just mediocre. If it's just mediocre, running it in circles isn't going to make it better. If it's a mix of good and bad, maybe we can recover the good. So traditionally, we'll just simply cut it, okay, on small lots. And I see a few companies that will store that middling and do something else with it. That typically means they have another use for it, okay? You can never really add it back to the same lot lever. The most common thing was much like the little Forsberg you see here, where it's recirculated over the deck. That was a trapezoidal deck. There's a short travel path for the lights, and it wouldn't be completely separated. And by bringing that back around, it gave it another chance basically to separate out. I see a lot of that on seed corn, small lots, and so forth. When you get into the larger volume field crops, I frequently see a second gravity used. Maybe they bought a big new gravity and they used the older gravity to recover the middling. Sometimes I'll see a color sorter or a belt separator used. if you can imagine, like if the only thing wrong with the middling product was that it had dark seed in it, a small color sorter might be able to recover that. So biggest thing, if you are recirculating this product, try to minimize the amount that's recirculating. I've been to plants where 50% of the product from the gravity is running back over the same gravity. The gravity is overloaded. It's not doing a good job. Maybe it should be 10 or 15%. That depends on the application, but you can definitely overdo recirculation. Okay. Any gravity separator questions while I'm here? I can assure you there's plenty of slides, but are there other things that we should cover here? We had a good test weight question before. If not, I'm going to go ahead and plow into color sorters. Again, probably a little less of this. I don't know how many of them are out there in your market. We see plenty of them going into corn plants, and they're gradually going into soybean plants as well. The first ones I did were actually for popcorn, food grade product, again, trying to get things out for retail. I frequently show things like these rejects. The accepts and rejects are actually the two streams off of a color sorter. It's necessarily good and bad, but usually the rejects are the bad. The junior high kids will tell me these are gross and they would never want them in their package at the store. So you can see why there was an advantage to sorting that product up front. Foreign material is the other big reason for popcorn, but it happens to be Satake and what we're Sortex or Buehler machines here. I have several of those in our lab. The other machines tend to visit, so you're going to see those more often in this, but that isn't necessarily an endorsement or disadvantage of one or the others. I have lots of pictures of other slides, but not enough time to show them all. Okay, so when we're dealing with color sorters, we're dealing with some interaction of light. We dealt with gravities, on density and screens with size or perhaps, but you can have different parts of the electromagnetic spectrum. And in this case, perhaps most of it's going to be visible light because that's what we can see. It's also going to be reflected light because if you're looking at the surface of the seed, you're seeing light reflect from that surface. And so if we're trying to get discolored defects, we want something similar. But I do see translucent sorts occasionally where the light goes through it. We're basically candling it. I see a fair amount of near infrared. At this point, that's primarily foreign material removal, but that's an area where the machines are evolving pretty fast. There's been a few UV machines that would use a fluorescent type sort as well. But we'll focus mostly on visible today. And you may remember from high school physics that if you had a prism, you could separate visible light, like what's coming from the window over here, into different colors, and those correspond to different wavelengths of light. So we can pick a certain wavelength perhaps and accentuate the contrast and then use combinations of them to improve our separation. We're dealing with something in color separation. So it's a light and dark. It's not always as easy as this one. I like to joke with the students here that we've got a seed identification quiz that happens to be roasted in green coffee beans. When that lot came in, it was 1,200 pounds of it. I've had coffee beans in about 6 times. The biggest lot was 5,000 pounds. So our idea of a sample is a bit bigger than the rest of the building. But this is actually an interesting separation. It smells great coming through the tower. We can get discolored seed because that's what we're doing. It's rarely ever this clean cut, okay? Usually you need something much more subtle. Broken seed depends on whether there's actually a color difference. I've seen where you could maybe pick up a shadow, off shriveled seed, but a straight color sorter is just looking for color differences. It doesn't really see density, but sometimes you can remove low density if it's also discolored, if there's an overlap in those two curves. This is one example where a gravity will give you almost a straight line because there's a huge difference in the density of those two products. On the roasted's a lot lighter. Moisture's been removed. But then maybe we finish up with a color sorter, or you can do it all in a color sorter, but it'll take several passes. Okay, if it's a 50-50 mix is what that was. Okay, so a couple quick seed examples here. This is soybeans. If you don't happen to run across those in your territory, but very colorful product. It's one reason I see people trying to use they'll use like a cleaner and then a spiral or a belt and a color sorter perhaps. But you can see some of the purple stain in here. It's a physiological defect. But immatures, other things, I've had students joke that they were going to put this in a little fancy bottle and tie a ribbon around it and sell it at Walmart. Might bring more than the seed, but farmer's market perhaps. But in corn, we're typically removing darks or maybe some brights, which is tricky because there's bright parts on the yellow dent corn as well. In Iowa, we have lots and lots of yellow dent pollen floating around and during the summer. And so one common thing we have, if it's other types of corn, classes of corn, we can be frequently removing yellow dent from white corn or from red corn or from blue corn or orange corn, whatever other kinds of corn we might have out there, because they've been cross-contaminated with the yellow dent pollen. Another big advantage, I mentioned that a gravity can't run very small lots because you can't cover the deck adequately. A color sorter can theoretically color sort individual seeds. Okay, so we're looking at actually a small lot here. They would use these for breeding applications, but that was the student doing this for 3 years was running 800 to 1,000 of those lots through a color sorter that we tweaked for small lots, and could do it more consistently than he could do it individually. Okay, we had a wheat question before. This is separating white and red classes of wheat for breeding application, maybe only 5 bushels total, but trying to get it as close as possible to pure. Okay, sunflowers, we're dealing here with taking a black seed out of a black defect in some cases. So this was a case where near infrared, because they use both visible light and near infrared and sometimes a few more combinations. The bane of this is usually something called sclerotia. It's a black defect that by the time it reaches the color sorter is the same size and shape and density as the seed itself. And so, and it's kind of bad in confectionery and for pathological reasons as well, but can be removed with reasonable efficiency. Okay, and then you can also get spot defects. This was, it's a long story here, but basically we're picking out seeds that had little bug bites that subsequently became moldy, and we could kick those out as long as the product is presented towards the camera. A color sorter typically has a camera at front and rear view. If it's turned sideways, it may not see that. Okay, so a couple quick examples. I mentioned I could show you slides quite a while here, but the larger versions of the Sortex machines that I've shown you look something more like this, to where we might have, and they've gone to LED lights instead of fluorescents that used to be in most of them. The Satake machines, the monochromatic machines look more like the upper right. You start to see some RGB machines, which is really kind of the trend in the business here right now. I want to bring up just a few things to talk about, as far as how these things work. I'm going to go a little bit quick here, so bear with me to try to get closer to lunch. But here's just an older Sortex machine and a cross section of that. So basically, you have a feeder on top. You have a chute that basically accelerates and singulates the product as it goes down past in front of the cameras. And we basically try to look at it in the front and rear view. And then based on the signal, there's air ejectors that fire at it and basically blow the rejects out, which are normally the bad seed. So you wind up with 2 streams of rejects and accepts. Okay, there's 3 things that any color sorter has to do. Basically, it's got to convey the product past the cameras properly at a single stream so it can see them all. And there's some issues on trying to go fast enough to get capacity and spaced far enough apart to get an efficient separation without losing too much yield. We have to detect it, and that's where one of the subsequent slides here gets into the ability to tell the difference between good and bad, and then compare that signal to something that tells the thing to remove it. And so timing of those air ejectors is another thing that we talk quite a bit about during the workshops. Okay, this next one gets a little more involved, but there's a signal. On the older ones, it's a voltage, but there's a signal based on the intensity, how dark the product may be. And you'll see here machines being called monochromatic, bichromatic, or RGB. And I just want to help explain that if you've got someone talking to you about the differences in machines, because it makes a difference in what they can separate. The traditional machines had basically one signal. We get back to my bell-shaped curve. They would try to center the middle of that bell-shaped curve. That's the relative lightness or darkness of the good product. Some's a little darker than the others. They put that in the middle. There's another probability curve basically for the dark defects or the light defects. And then there's one number that basically can be adjusted to tell it how much dark to remove. If you raise that too much, you start to carve into the good seed. And likewise, a light sort. There were some machines that did an independent sort. It's basically like having 2 color sorters, one after the other. Basically, if it saw it in dark or if it saw it in light, then it might remove it. And there's a few combinations. This has kind of gone away to be replaced with what was called a bichromatic, or the next step will be the RGB machines. A bichromatic machine allows it to look at the interaction of those 2 things. So that in addition to saying that it's dark in one and light in the other, or you can say that you can look at combinations thereof. Basically, red versus green or red versus blue were common visible spectrum ones. Red versus infrared is harder to show on a PowerPoint slide. One of the ones I have basically has these trip lines that can be used to box in the good seed, and any defect that goes outside of the box basically tries to be removed. The newer machines, you started to see ovoids that basically surround the good seed, and then there were defect perimeters around here. So they were different. Like these are brights, these are darks. Maybe on this up here on red versus green, I might have some kind of reddish type seeds or green immatures or something, down on this side. And so we can have different defect classes, color defect classes that we can have individual sensitivities for. It doesn't take too much to figure out that if I can plot red versus green or red versus blue, that I could do red, green, and blue in a cube and have a three-dimensional color map, which is really the way the RGB machines are going. Almost every new visible spectrum machine I see come on the market today is an RGB unit, okay, or some more advanced things. Okay, then the other thing you'll typically see people talk about doing is shape sorting. I mentioned this kind of in contrast to the spirals, but this is a two-dimensional profile. It depends on how the seed is oriented, but usually you can look for area. It works better on things like soybean than it does on corn that could fall this way. Soybeans being roughly spherical makes it a bit easier. Area and length are usually pretty useful, maybe circularity depending on product presentation, but it's definitely an evolving area, happens quite a bit. I mentioned that in gravities, we sometimes resort the middling. On color sorters, this is back to my infamous coffee. A single sort might not get there by itself, and so we have to go at it again. We frequently recirculate either the good or the bad product, depending on what it is. More often, they're trying to recover good from the reject in a commercial plant here in the Midwest. So I'm going to show you just a couple of quick examples. At the workshops, we can get into more detail on various configurations. But the idea here was there was a 4-module machine running the primary product. The rejects were then going to the single module machine, the smaller one over here, and recovering the good seed from the reject. So here's just an example of what that would look like in a soybean facility. So we basically have there's a couple of handling systems happening here, but basically we're sorting it the first time. This is an intermediate product that's then being sorted again. The accepts from the resort are going down here, and you still see that there's some defects there. That actually gets blended back with the incoming product, give it a chance to get these remaining darks back out of there. At the end of the day, this is basically our discard over here. Our good seed is over here. These two in the center are just intermediate products that kind of whirl around within the process. Okay, big problem, again, we talked about like measure and test weight on a gravity. How do you tell if a color sorter is doing its job? You typically have to look at things, look at samples. So I wind up being very interested in, automating some of this thing, trying to be consistent. Humans aren't consistent from one day to the next or one operator to the next. So we're gradually doing more work with optical imaging to try to help make a better tool that gets results more quickly for that. So with that, as we start, we've kind of got through our separation part. I want to just mention again, I promised Dr. Taylor there'd be one treater slide. I have some more that are hidden here, but this is one I put in years back. I happened to be back there doing some training, but basically we wind up, most of the traditional treatments were put on for pathogen protection. There's various things that can be done to improve planter performance. As you get into some of the specialty seeds, you see more buildup or pelleting occurring. Some of that is gradually migrating into the field crops as well. But this happened like sugar beets would be an example where they'd make them more spherical, or canola where they'd make them larger in a rapeseed so they plant a little bit better. But you're going to hear a lot more of that from Peter Marks this afternoon. And again, the whole business on treating, to get good results from your treater, sometimes proper preparation is important. We talked about how we have problems in the seed plant if that combine operator didn't do his job, or if the seed came in, it was moldy because it wasn't dried properly. When we start talking about treating, if we leave a lot of foreign material in there, some of your treatment's going to stick to that dust and dirt that's in there, and instead of the seed. You're more likely to get dust off. There's going to be problems that occur because of that. So we want to get a nice, clean product to the treater before we go on to it. The pelleting gets to be an interesting example. We got into some things with some flower seed. We're removing little hairs from the flower, but they didn't think that was a problem because they don't germinate. Well, it turns out that when they pellet it, the little hairs would also get pelleted, and they look just like a seed when they got to the seed lab. And they would try to plant them, and by removing the little hairs before they pelleted, their germination results went up, which was kind of an interesting story. So with that, we get into different packaging, again, beyond the scope of this, but various things may happen from little foil bags to large bulk bags or even true bulk out here. Winds up in the warehouse, and proper storage conditions again are important to deliver good product, and it could be subject for another presentation someday. So with that, I'll leave you read through some of this. Oops, sorry, back up. I didn't intend for you to read it that fast. Are there any questions I can deal with here quick before I show you one more slide and then finish up here for the credits? Did we put everyone to sleep? We talked about efficiency and, like a batting average. So if I'm trying to cure insomnia, are we at 100%? Is there anyone that's still awake?
Well, I'm awake, Alan, and
All right. Okay.
I appreciate this.
This stuff helps with that.
It does indeed, but no, please feel free. Anybody, as an attendee to the, this is a font of information and a lot of information. But if you have a question, or you can put it in the chat, again, Alan is the person. And are you going to talk a little bit more about the short courses then before you wrap up? Okay.
We'll go to this one. Well, we actually have something called a short course. It was virtual this year, but the workshops, this is my perhaps optimistic schedule we put together for 2021. There's at this point still a high probability I have to turn this into a virtual program or something. We had to cancel these last year, and we put some other things together. It gave us an opportunity to put some other content, and we've been gradually working on better ways, kind of like a little bit of what you're seeing here today, better ways to deliver information remotely. But at least there's the type of things that we would typically go through. I promised to give you email address, and this is the website for it. We typically try to formalize these dates by the ASTA meeting in Chicago, which is next week, and also virtually. But I'll share at least some, what we think are going to be the dates if the COVID situation improves, where people can physically visit us on campus. Otherwise, you could watch that website, and hopefully something else will show up, or drop me an email. Again, appreciate your patience here today. We'd love, like you saw on the poster, it's kind of neat when people can physically come there, but the advantage of remote delivery is sometimes that we spend less time on airplanes and maybe a larger audience. So appreciate that opportunity. And that I promised Doctor, I can come back to this if we need, but promised Dr. Taylor would show this at the end for those of you that might need some credits.
Right, good.
Any questions while that's up there?
Yeah, this is your opportunity with Alan, and again, his large array of knowledge and experience with so many different seeds and working with so much different seed cleaning equipment.
Now, sometimes it's a case where an awful lot about a very narrow field. I've spent my whole career pretty much around seed plants, and some food grade, what I call food grade seeds, like the popcorn, dry beans, cereal grains, this type of thing. Very little in the commodity grain. Okay, I haven't done a lot with that. I get to some of those facilities. I've refurbished a few of them, but in the 22 years out there working, designing plants, now I mostly talk about them. But we see a much more diverse array of different seeds. Hopefully at some point we can bring the hemp seeds in and help answer those questions better. But chestnuts, hazelnuts, Iowa ones that are being domesticated. I mean, a lot of funny things wander through our facility. Again, a small part of a bunch of different plants. So sometimes learning something, for instance, we've done some work I didn't show you here with Cercis, but it turns out that many of the methods we had developed for flax worked, and so you can kind of build on what you learned. Okay.
Okay, well, this does take us to noon, and again, I want to thank you and give you a nice thumbs up for your presentation, and a virtual clapping there as well.
Okay.
Well, so really appreciate Alan. Again, such an excellent presentation with so much information provided. I think I have to go back and listen to the recording sometime just to pull out some some individual information where you were going, talking about some of the equipment. So again, thank you so much.
All right. Well, again, I'm going to give you a thumbs up on your end. It's a neat opportunity to reach. We get some people in from various companies up there doing pumpkins, doing organic white corn and things like this. Some flint corns and stuff have come in, samples and so forth. And we've some small family-owned companies have been out. One of their sons came out and came to Iowa State after a workshop. And he's now an agronomist that's working for one of the seed companies. So it's a neat opportunity for collaboration, and much appreciate that. So,
Okay.
For me, I've got another hour till lunch, but so I could stay on, but I suspect if you've got other things that you'd like to do, and I would recommend trying to catch that presentation at 1, and some of the others later this afternoon will get more into product and performance, but the equipment part, you get into treating and things that affect those results, should be covered, and for a range of seeds that are not probably just corn and soybeans there either. So
yeah, thank you.
This has been a production of Cornell University, on the web at cornell.edu.